Here's the second part of the video going through questions 5, 6 and 7. So question 5, use the substitution x equals u squared to show that this complicated integral equals the integral of 2 over ua with respect to u, where a is an expression to be found, so not a number to be found, but an expression to be found. So obviously the first thing is always to differentiate what you've been given as your substitution, or what you've chosen as your substitution. In this case we've got to be careful. If I think about a y equals situation and then dy by dx, I've actually got x in the usual position that y is in. So my substitution here and differentiating this leaves me to, if x equals u squared, then dx by du equals 2u, just differentiating both sides with respect to u. And I want a replacement for dx, so that leads me to dx equals 2u du. Very easy to get that the wrong way around at the beginning. So this is the most important bit, is this, for any substitution, is differentiating your substitution and replacing the dx with something. Okay, I've got no limits here, so it's an indefinite integral, so I'm not needing to substitute limits. I do need to think about how I'm going to substitute these though. I've got, obviously, x is going to be replaced with u squared, and how I'm going to change that bit. So if x equals u squared, then root x equals u, so I just need to substitute in u for that. So completing the full substitution, I've got 1 over x, 2 root x minus 1 with respect to x. Exchanging all the elements of that is the same as the integral of 1 over x replaced with u squared, this bit replaced with 2u minus 1, and dx replaced with 2u du. Then I can start cancelling things. That u will cancel with one of those, leaving me with just u there. So that leaves me with the integral of 2 over u times 2u minus 1 with respect to u. So in order to get rid of that, I need to work out, oh, it's done. Sorry, part A is done because I have 2 over u times a, so I've already completed part A. A equals 2u minus 1 in this case. Part B, hence show that this integral, I've now got limits, equals 2 ln a over b, where a over b are integers to be determined. So I can see that my limits now are from 1 to 9, so that's the first thing I'm going to need to do, is to work out my new limits in terms of u. So my limits in terms of x were 9 and 1. Limits in terms of u are therefore square root of that, 3. And square root of 1, 1. In order to integrate this, I need to think about partial fractions. Otherwise, I would have 2u squared minus u on the denominator, and I can't do anything with that. If I think about that denominator, I can't deal with an expression here to different powers of u. So, in order to split this up, I'm going to need to use partial fractions. So, I know that 2 over u, 2u minus 1, is equal to a over u plus b over 2u minus 1. That means that 2 equals, cross multiply, a times 2u minus 1 plus b times u, cross multiplying there. And now I need to eliminate these, so when u equals 0, that's going to get rid of b. still got 2 on this side. 2 equals 2 times 0 minus 1. It's minus 1a, which is just minus a, and that tells me that a equals minus 2. To get rid of this bracket, I need to have u equals a half. So when u equals a half, 2 equals, that bracket equals 0, so no a and half b, and therefore b equals 4. So I've now set everything up for my second. It's the same substitution really, but I've now got the limits to go in as well. So the integral that I've been asked to find, 1 to 9 of 1 over x 2 root x minus 1 with respect to x, is equal to the integral from 1 to 3 in terms of u. And I'm going to replace this 2 over u to u minus 1 with a minus 2 over u plus b, which is 4 over 2u minus 1 with respect to u. Doing that integral, I've got a first fraction is just going to be ln u is on the denominator with a minus 2 in front, minus 2 ln u, plus, if I differentiated that, I would get 2 on the numerator, and I would need to multiply that by 2 to get 4. So this is 2 ln 2u minus 1. And that's all from 1 to 3. That's good, because so far I just know I'm trying to get to something with 2 ln in it, and this is looking like it's heading in the right direction, so I'll keep going with this. So when u is 3, I've got minus 2 ln 3 plus 2 ln 2, 3 is a 6 minus 1 plus 2 ln 5. Minus, when u is 1, minus 2 ln 1 plus, I'll put that in the brackets with it, 2 ln 2 minus 1 is 1 plus 2 ln 1. And of course ln 1 is 0, so both of those are 0, so I end up with minus 2 ln 3 plus 2 ln 5, which is also, it's easier just to swap these around, 2 ln 5 minus 2 ln 3, which equals 2 in front of both, ln 5 over 3. I can only do that using the 2 in front of both when it's the same number in front of both, as sort of factorising each term, and then using the laws of logarithms to combine them. So that's got to where I needed it to. 2 ln a over b, where a over b are integers to be determined. So that's that one. I think if anyone didn't use substitution, not substitution, I mean partial fractions, they ended up with a lot of trouble there, trying to integrate that. So partial fractions is the way to go whenever you've got these two denominators, and they kind of set it up in that way for us by showing it in the question that u times some other expression was the substitution for that, or was the result of the substitution for that. Okay, question 6 involves parametric equations, and in this we've got x equals ln of t plus 2, y equals 1 over t plus 1 for t being greater than minus 2/3. The finite region R, shown in the figure 4 shaded, is bounded by the curve C, the line with equation x equals ln 2, and the line with equation x equals ln 4. So in this we are clearly trying to find our integral from ln 2 to ln 4 of whatever the function y is with respect to x. That's our standard, and because it's parametric we automatically convert that into something with new limits. Y times by dx by dt with respect to t. Those limits need to be in terms of t, so they used to be in terms of x. I think that's the first substitution I'm going to make. Limits are going to be x was ln 2, or ln 4 and ln 2. Therefore t is ln of t plus 2 equals x. That means that t plus 2 equals 4 for this one. Therefore t equals 2. And for this one, t plus 2 equals 2, because it's ln of each. Therefore t equals 0. So I can put those limits there, 0 to 2 of this idea here. The next thing we need is dx by dt. So I'm going to take x and differentiate it. If x is ln of t plus 2, then dx by dt equals the derivative of this bit, t plus 2, which is just 1 over t plus 2. So I'm now ready to substitute all of that in. My area equals the integral from 0 to 2 of y, which is 1 over t plus 1, times by dx by dt, which is 1 over t plus 2, with respect to t. Now I can see this being a partial fraction situation because I've got two linear denominators there multiplied together. So that's the next step. Again, partial fractions. I suppose in an actual A-level exam paper, it's definitely not impossible that you use partial fractions in two questions. It's kind of unlikely in the same paper, but it's, like I say, it's certainly not impossible. It's happened before, so always look out for partial fractions when you're integrating. So in this case, I've got 1 over t plus 1, t plus 2, equal to a over t plus 1, plus b over t plus 2. Same process as before. I'm going to say, therefore, that numerators equal 1 equals a times t plus 2, cross multiplying, plus b times t plus 1. When t equals 0, I've still got 1 on this side. Not 0, I don't want 0 at all. Sorry, I'm going to say when t equals minus 2 first of all to get rid of a. 1 on this side equals 0 plus minus 2 plus 1 in there is minus 1 minus b. Therefore b is minus 1. And when t equals minus 1, I've got 1 on the left hand side and 2 minus 1 is a, and of course that's 0, so that tells us that a equals 1. So finding the area using that again, the area R equals the integral from 0 to 2 of our partial fractions now. So I've got 1 over t plus 1 plus, it would be minus 1, so I'm going to put minus 1 over t plus 2 with respect to t. Integrating that, I've got lns, so ln of t plus 1 minus the ln of t plus 2 from 0 to 2. So that equals ln of 3 minus ln 4 minus ln of 1, 0 plus 1, minus ln of 0 plus 2, which is 2. So that ln 1 is 0, so that will just disappear. So that gives me ln 3 minus ln 4 minus minus ln 2, so that's plus ln 2, and that gives me, so I've got 3 times by 2, which is 6 over 4, using laws of logarithms, which is ln 3/2, simplifying that fraction. And that is my answer for that question. Final question is one of these modelling questions. So this is always about a very careful setup. A bottle of water is put into a refrigerator. The temperature inside the refrigerator remains constant at 3 degrees C. And T minutes after the bottle is placed in the refrigerator, the temperature of the water in the bottle is theta. So theta is the temperature in the water, not the fridge. The rate of change of temperature of the water in the bottle, so that's d theta by dt, is modelled by this differential equation. D theta by dt equals 3 minus theta over 125. By solving the differential equation, show that theta equals ae to the power of bt plus 3, where a is a constant and b is a constant to be found, and they've separated those two because we are going to be finding what value b is, and a is presumably just going to be left as a, it's just a constant. So first of all, let's separate these variables. If d theta by dt equals 3 minus theta over 125, we want everything involving theta on the left-hand side and everything not involving theta on the right-hand side. And I'm going to integrate both of those, so that means that dividing by 3 minus theta puts it there. Integrating that side with respect to theta is equal to the integral of 1 over 125, leaving it where it is on that side with respect to t. Integrating those things with respect to theta, that is ln of 3 minus theta, but of course there's a minus inside the bracket, so I'm going to put minus ln of 3 minus theta in there. Modulus equals t over 125. Or probably easier, put as a number in front, 1 over 125 t plus c. Now the confusing thing here is, because this is a modulus, I'm just looking for the difference between 3 minus theta, and seeing as the water in the bottle is likely to be warmer than the water, so a higher value, if I put 3 minus, say, 10 in there, I would get minus 7, and then the ln would turn this into a positive value. I mean, the modulus signs would turn this into a positive value. Has to be positive in order to be able to apply ln to it. So actually, when we see this, we could swap those round. If theta is going to be higher, theta minus 3, it would give me the same value. If theta was 10, for example, instead of getting minus 7 in there, I'd just directly get 7. This doesn't matter so much because everything will resolve itself in the end, but it is worth knowing about, particularly if you're looking at mark schemes. So this would be minus ln of theta minus 3, and I just put that in brackets because theta is going to be higher than the temperature of the water, than the fridge, equals 1 over 125 t plus c. Therefore, I'm going to multiply everything by minus 1 so that I've got this ln ready to apply the power of e to both sides. So let's just times everything by minus 1 and take it up here. That gives me ln of theta minus 3 equals minus 1 over 125 t, technically minus c, but because c is just a constant, I'm just going to put plus c, because it doesn't matter whether it's a positive or negative number, it is just a constant on the end. Now we do e to the power of both sides. That gives me theta minus 3 equals e to the power of minus 1 over 125 t plus c, all to the power of. I rewrite that plus c, remember that is e to the power of c, times by e to the power of c, just as a. So I've now got a times by e to the power of minus 1 over 125 t. That's also minus 0.008t. So I'm going to switch that over in the final thing. The fraction is perfectly good. I'm going to bring 3 to that side, so that gives me theta equals a e to the power of minus 0.008t plus 3. Using that fraction is perfectly good enough for the marks. Like I said, if you had done 3 minus theta, it would have been slightly more complicated dealing with the minus sign, but you would have ended up with just minus a in front instead, which again is fine because a is just a number, so it can be a negative number. And now we've reached the end and we found that a is a constant as we thought, and b equals minus 1 over 125 or minus 0.008 in there. Okay, in part B, given that the temperature of the water in the bottle when it was put in the refrigerator was 16 degrees centigrade, so that is when T equals 0, when it was put in the refrigerator. That's going to be our link pair, T equals 0 and theta equals 16. Find the time taken for the temperature of the water in the bottle to fall to 10 degrees C, giving your answer to the nearest minute, and T is in minutes, so we're going to not have to adapt our answer for T, we'll just be able to round our answer to T. So, first thing to do here is to use what we've already got as our formula. Theta equals a e to the minus 0.008t plus 3. Set that equal to 16 because this is our first value. When t equals 16, that equals a times e to the minus 0.008 times by 0 because it's when t equals 0 plus 3. That's minus 3 from both sides. Gives us 13 equals a times e to the 0, which is 1. Therefore, a equals 13. So we now have our formula with 13 in it, and we're using the 10 degrees. So 10 degrees equals a as 13 now, times by e to the minus 0.008t plus 3. Again, take 3 from both sides, that gives me 7 equals 13e to the minus 0.008t. Divide by 13, 7 thirteenths equals e to the minus 0.008t. And in order to undo this, we're going to have to take logs of both sides, so ln. And it's worth bearing in mind that ln 7 thirteenths is going to be a negative output because it's ln of less than 1. I've got rid of the e by taking lns. So that is minus 0.008t. And therefore t equals ln 7 thirteenths over minus 0.008. We know that that's negative and that's negative, so we should get a positive answer, which we get as 77.3799, which rounds to 77 minutes to the nearest minute. It's just worth saying that t could have equaled, if you used fractions all the way through, t would have been written as minus 125 ln 7 over 13. That's the same as that fraction over minus 0.008. Okay, so that's the final answer, 77 minutes. Again, these questions are always about, or most often about, understanding the model in the first part and being able to use separation of variables. This technique, separating the variables to integrate both sides, or also known as differential equations, to get our basic formula that link them, then using a link value like t equals 0 and theta equals 16 in order to find the missing constant of a, and then plugging into that formula to get a final answer. So this does follow that kind of formulaic setup of these questions. Okay, that's it for these ones. Hope some of that was useful.